In this tutorial, we'll show you a new way of developing your model class. So in the previous labs and exercises, we have only a single model class like a person or a taxpayer or game. In these classes, you have only attributes of simple types like an int, string, double, or character. So these are the simple types that can really just make sure you have only a single class without expanding further. However, in general, you can have more than one classes for your model components. So that's something we would like to show you for this particular tutorial. So what we'll do is we'll define two classes in your model components, and then we'll show you how you can link one to another. So what we'll do is we're going to use a simple point class, which represents a two-dimensional point, which you learn from the lectures. And then we'll also show you how you can have a point collector class, which will somehow declare attributes of point type. So this is the new bits that we want to learn. We want to have attributes in a class, and attributes do not just have simple types like an integer, boolean, character, or string, or double. They can simply have a type that represents another class. Okay, that's something we want to learn. Okay, the way we do this tutorial, we are not going to develop any new app. We're simply just going to show you some model classes and also tester. So you can simply just translate the same idea into your app developments. Okay, let's now launch your Android Studio, and I'm just using the latest version of Android Studio, but you should really try to make sure whatever you develop can be successfully also ported into the lab machine. Okay, so now let's start a new Android Studio project, and then for the application name, let's call that reference attributes. How about that? Reference attributes. Basically, we're going to show you the attributes whose types are reference classes rather than just primitive. Okay, and then for the company domain, let's say EECS 1022, and then for the project location, just store to wherever you store your work for 1022, and then we say next, and then say next. Now we simply just go to the option where we say add no activity, which means we don't really have to develop any app for this particular tutorial, but in your lab exercises, of course, you have to start with empty activity. Okay, and then we'll say finish. So we'll only use two model classes, namely point and point collector, and also a tester class to illustrate the ideas. And then we'll also do some iPad illustration to show you how the visualization looks like in this new pattern of developing your model classes. Okay, as soon as the Gradle has finished building, then we'll start developing the first class, which is the point. And you already learned about this class in the lectures previously. So we'll do this class rather quickly. The more interesting bit is about how you can define another class, which is going to declare attributes of type point. So that's the interesting part you haven't seen so far. Okay, so let's go to project over here, under app and under Java. So now we will see that we have this package here, EECS 1022 reference attributes. So that's our package. Okay, so now let's first of all create a new class for our model. Okay, so in this particular tutorial, we want to show you that in your model components for developing your app, in general, you can have as many classes as you like, rather than just one single class. For a previous lab, we just wanted to make it simple for you to learn. But now we want to show you the slightly more general case, which is much more likely the case in your future development. You might need more than one classes. Okay, the first class we're going to create will be, let's right click on this package here and say new Java class. Let's call that just point. Okay, and then let's create a point class very quickly. Okay. So let me just delete this automatically generated code. And then, so let's say we got the points, two-dimensional point, which got x and y coordinates. So we say double x and double y. Okay? And then for the constructor, also as we learned, the constructor with the same name as a class, double x, double y. As you can see, the x and y parameter names over here clash with the attribute names. So we must use this keyword to disambiguate, to make sure we say this.x is really referring to the attribute x. and then it's assigned to x over here, and the x on the right hand side is referring to the parameter over here. Okay, we have discussed this in the class, so hopefully this makes sense to you. And this y is assigned to y. Okay, that's a very simple constructor over here. And then we're also going to define two methods just for illustration. We want to define one mutator which will move up the points by certain units, and also we're going to define our standard accessor method for displaying the string description for the point object toString method. Okay, let's do that very quickly. So now the first method will be move up. So it's a mutator method which returns void. And then let's say move up. We're going to move out the current objects by certain units. So let's say double units. Okay. So now because if you move up, it will only change the y coordinate value. So say this dot y plus equal units. Okay. And then we have a, let me just do some annotation for you. And again, this is the standard way of organizing your Java class. You do not have to really follow this order always, but it's good practice for you to follow. Okay. So now over here we got attributes, and here we have constructor. We may have more than one versions of constructor. For the point class, I will show you only the one version that you have seen in the class. But in the point collector class, which I will create in a moment, I will show you two different variants. Okay. So now this one here is a mutator method. And we have another method here for accessor, which will return something that's not void. So let's say you can simply use a code completion mechanism toString, and then it will give you this toString method. So do not worry too much about the override over here. You just gotta keep it. Okay. So we are not going to address an advanced topic in Java called inheritance, which you will learn later in the course called 2030. But for this course here, you only got to understand override simply means we're going to redefine the behavior of the toString method. Okay, the toString method is a special method which is available to every class you're trying to define. Okay, and that's all you gotta know. Okay, but of course you don't memorize this. Whenever you use Android Studio to automatically generate the toString method for you, it's going to have this add override tag. So just keep it. Okay. So now, what should be the string description for the point class? Okay, so now we can simply print out the x and y coordinates. So you can say a string, I would say s, initially empty, and then we're going to accumulate the string by, let's say s plus equal, let's say parentheses, opening parentheses, plus the value of x, you can say this dot x if you wish, plus separated by comma and space, and plus this dot y, and then plus closing parentheses. And then at the moment it says that you have a missing return statement. So remember, for every accessor method which returns something that is not void, you have to make sure you return a value that's compatible with this return type. So you may have multiple return statements in your accessor method, that's okay. However, it's more recommended you follow a simple pattern, which means you can do whatever manipulation of your values as you like, but eventually the last line of your accessor method is going to be a return. Okay, I just say return s. It's a much easier way to make sure you don't have any compiler errors like missing return statements. Okay, so that's about our point class over here. So what we'll do now, we will actually create a tester class to actually illustrate to you how we can manipulate the point objects. And then I'll give you some intuition about what it means when we try to assign reference variables in the tester. And then we'll move on to the second model class called point collector, which will do exactly the same thing. Okay, let's now create a tester. So we'll go step by step. So right click on the package and then say new Java class, and let's call that point tester. Okay, so let's also delete this automatically generated comments here, and then we're gonna define a main method: public static void main string args. Okay, so now we have this tester over here. Let's try to do some simple manipulation. Okay, if I say point and then I say p1 is assigned to new point, and then let's say we simply got 2 and 3. Okay, like that. And then we also got point P2 is new point, let's say, let me just make sure you review this. Okay, 4 and 5, just check your understanding. Let's say 4 and 5. Okay, we simply got 2 point objects to be created. So now, what I want to do first of all is to review what you learned so far in the object classes. So if we say P1 not equal to P2, okay, what does that mean? Basically, remember we said before, when we say P1 and P2 over here, let's try to visualize this very quickly and then see the debugger. Okay, so now we got P1 and P2, 2, 3, and 4, 5. Let's look at that very quickly. Okay, so now basically, the first line over there, when we say P1 is assigned to new points 2, 3. What it does is, so we created an object in the memory of type points. And then we have every point has 2 attributes. If you go back to the point, you got 2 attributes x and y. That determines the structure for the point objects. So there's going to be x and y. And in this case, we are calling the constructor to create x being 2 and y being 3. Okay, so what we will get is we get 2 here and 3 here. And then we say that the reference variable P1 is going to store the address of this new object. So that means P1 is going to store the address of this particular object over here. So conceptually, we can think about P1 is going to point to this object. Okay, that's just a review of what we have learned so far. What about the second line? It's going to be done in a similar way. So we are going to create a separate object. Every time when you see a separate use of a new keyword, that means we're going to create a separate object in the memory. So now it's going to be another object over here, and then we have over here points, and then we have also x and y. And now in this second line of initialization over here, x will be assigned to 4 and y will be assigned to 5. Okay, so now we have 4 and 5 over here, and then you can see on the assignment over here is going to say whatever this object we have just created, we're going to store its address into P2. Okay, so that means P2 is going to point to that particular object. That's what we have. Okay, so we have done 2 object creations. Okay, so far so good. So now, before I show you the new information which you have to learn for this particular tutorial series, let's now first of all check this. When we say P1 is not equal to P2, so what does that mean? So this means checking to see P1 and P2 do not, because you can see there's an exclamation mark over here, that means it's not equal to, do not store the same point address. That is, P1 and P2 do not point to the same point objects. And this is indeed the case, because if you go back here, you can see P1 and P2, indeed they don't point to the same point objects. Okay, so now let's verify this very quickly. So I can right click on point tester over here. Let's right click on that, and let's say run the main method. Okay, let's just make sure it's really going to return true. Okay, and then we'll do the next illustration. Okay, it's going to display the result in the console. That means they are indeed not equal. Okay, so now let me just make some comments here so you can make it more sensible. Okay, so now we can say reference variable P1 and P2 store different addresses. Okay, they simply store different addresses, and then you have to make sure you bracket this together. So that means we're going to so this expression itself is a Boolean value. It's going to compare P1 and P2, the 2 addresses, and then it's going to be either true or false. And then whatever the result it is, we're going to concatenate that with this string description here. Okay, so let's just try one more time. Okay, click on the play, and then it's going to update the result. Okay, you can see that reference variables P1 and P2 store different addresses, and this is indeed the case. So that's true. Okay, so now let's now go to the let's now again verify this in the debugger. Okay, again, you should really, up to now, you should really know how to use a debugger, which is very important skill for you to pick up from this course. If you click on the breakpoint over here, okay, right before we try to execute this, we want to see exactly what P1 is and P2 is, okay? So now we're gonna do, rather than saying play, we're gonna do debug. If we click on that, let's see what's gonna happen, okay? It's gonna pause over here, right before we try to execute this system.out.println line. Okay? Now what I want you to see is this. You can see P1 over here, this line, P1 is equal to point at 491. Okay? That's indeed the address. Okay? Point at 490. So what does that mean? That means P1 itself is storing this particular address. And what's this address? This address is exactly where we can find this particular object in the memory. So again, you can see that P1 over here does not store the entire object like this. The entire object is not the case, okay? It's only going to store this address of this particular object. Similarly, if you look at P2 over here, you can see it's point at 491. You don't have to really make sense of this the absolute value of the address. All you gotta know is P1 and P2, they represent two different addresses, hence different objects. Okay, so now we can just annotate that very quickly. So P2 over here is storing this particular address point at 491. You can see 490 and 491, they are simply just different. And again, P2 does not store this entire object here. It does not. It simply stores its address to see where we can look up its location in the memory. Okay, it's point at 491. Okay, that's something, again, it's just a review. Okay, we can see both from the visualization, we can see P1 and P2, they're pointing to different objects. At the same time, we can also see from the debugger, you can see the addresses of these two reference variables, they simply store different values. Okay, so now let me start the debugger, and then now I want to illustrate something over here. Okay, let me just stop the debugger, point tester. Okay, what I want to do now is, I want to, first of all, review something very simple. Okay, so now let's try to review the following. If I have integer I is assigned to 23, okay, so that means I is a placeholder for integers, and I is currently holding the value 23. Okay, now think about what's going to happen here. If I say integer j, I say it is assigned to I. What does that mean? Okay, let's think about this visually, and then because the same principle is going to be applied if we change the variable type into point or any class. Okay, let's go to the iPad and illustrate this. Okay, I'll just use a new page over here. Let's just say integer I is assigned to 23. This is number one. Okay, so what does that mean? So number one is going to declare a placeholder called I, and then we store the value of 23 inside. Okay, that's what line number one would do. And then line number two, we say that integer j is assigned to I. So somehow we are trying to store the value that is currently stored in I into the target j. Remember, we said that this is the assignment source, this is the assignment target. Okay, as we learned for the elementary programming lecture. Okay, so what line number two would do is we simply declare another placeholder over here, and then we actually do the following. We declare the placeholder called j, and then the value of j is going to be a copy of the value that's currently stored in I. So we simply copy 23 into here. It's like a copy and paste as you usually do. Okay, that's it. Okay, so far so good. Okay, now I'm going to draw the same analogy into the context for reference variable. Okay, so now I'm going to ask you the following. Let's try to apply the same principle. Now, if I try the following to say point P3. Okay, how about just P1 and P2? If I say P1 is assigned to P2. So what does that mean? Okay, P1 is assigned to P2. Okay, apparently you can see that this is just another assignment. We are trying to somehow assign the value that is stored in P2 into P1. That's what we know. We just apply the same principle as saying, when you have this line over here, we are trying to assign the value that is stored in I into the placeholder for J. Okay, and over here we are trying to assign the value that is stored in P2, which is an address, into the placeholder called P1. Okay, let's try to see exactly how this is going to work out. Okay, again, let's go to iPad over here, and then we'll put it side by side. So now, if I try to say something like this, if I say P1 is assigned to P2, oh, is that the right order? Okay, P1 is assigned to P2. Okay, so we know that P2 is currently storing some address of some point objects. And P1 is a placeholder for point address. Okay, that's what we know very well. Okay, so now let's see exactly what's going to happen. Thanks to our previous illustration on the debugger, we know that P1 is storing this particular address and P2 is storing this particular address. Okay, let's visualize that in a slightly different way. You can think of now P1 is a placeholder which stores the address value point at 490. Okay, it looks very similar to this illustration here, very similar. Okay, it's just that in this case I is storing an integer value, but P1 is storing a point address. Okay, the same idea. Okay, and also similarly for P2 as the placeholder, we store the address, a different address, which is point at 491. Okay, that's what we have, right? Okay, so now if I just go back to this particular assignment over here, when I say P1 is assigned to P2, what does that mean? That means I'm going to somehow copy this value over here and then store that into P1, okay? Which means we're gonna replace. I'm gonna do the copy and paste, but if I already got something in the destination, I'll simply replace it, okay? So that means what this is going to do, when I try to copy whatever that is stored in P2 over here, which is an address for this object over here, I'm going to store that into P1, right? So I will replace whatever that is stored here before, and then I'm going to store this address over here. So that now it becomes point at 491. Okay, so this is exactly what this assignment will try to achieve. Okay, so this is actually just trying to draw the connection to how you can visualize the assignments for primitive types like integer, double, boolean, character, etc. Right? And now we're just trying to use the same principle to explain to you what does it really mean when you try to do an assignment of reference types. We simply, rather than copying like an integer, in this case, we are copying address of some objects over here. Okay, now once you understand this, which is a little bit lower level, very close to the hardware level, what we want you to understand, a much more effective way of doing this when you want to trace your object code is by changing the arrow. Okay, so now what we want to do is, let me use a different color here. Okay, let me use pink. Okay, when I say I'm going to copy this address over here and replace this one by the existing one that's stored in P1, that means P1 is not going to point to this object anymore because this address has been replaced. And then what is P1 going to point to after the assignments here? So P1 is now going to point to this object over here, which has the address point 491. Okay, so now that means right now we have two address holders, P1 and P2. They both store the same address to the same objects. Okay, you can see that after this, P1 is going to store point at 491. Okay, to make it more visual to you, you can see after this assignment here, we have P1 pointing to this object here. We have P2 also pointing to this object here. Okay, there is a special term for this. When you have more than one address holders that store the same address for the same objects, it's something called aliasing. Okay, I'll just write it down here. Aliasing. So aliasing, you can think about in the real life. Aliasing in real life, aliasing simply means a person has more than one names. Okay. However, in the context of object-oriented programming, we borrow the concept to say if you have a particular object over here, its address is actually stored in here and here. That means also aliasing. You can think about the object itself is like a person, and then you have the two placeholders like a names, like they have name either P1 or P2. Okay, they store the address of the same objects. Okay, so now after this, having said this much, so basically let me recap very quickly. When you do P1 is assigned to P2, basically you're just trying to replace the address that is stored in P1 by the address that is stored in P2. Okay, we just copy the address over here. Okay, and then visually speaking, you're just redirecting the arrow that is P1 is currently pointing to into this target object here. Okay. So now, what that means is, so now after P1 is assigned to P2, so now if I say system.out.println, okay, I'm gonna basically just do, actually copy the same line over here. So now let me just do one more line here, and then I'll change something and then make things better for you. Okay, so now we can say assigning P2 to P1, which means we are storing the address that is stored in P2 and store that into P1. Okay, so now after this, reference variables P1 and P2 store the same address, which means we can simply change this to be equal. Okay, and then we just do launch the program again. So this is what we'll see. Okay, you can see it's true. It's true that before we try to assign P2 to P1, P1 and P2 they point to different, they store different addresses. They point to different objects. However, after we do the assignments from P2 to P1, after that we actually have P1 and P2 storing the same address. Okay, you really want to study this simple example very carefully. So whenever we do assignments for reference variables. Reference variables actually store addresses of objects. So that means we're copying addresses of objects from one place to another. Visually speaking, we're just redirecting the arrows, like what we show over here. Okay, redirecting the arrow from here into here. Okay. Okay, that's about it. So now, one more thing I want to show you very quickly. One more thing. So now, let's say again. Let's try to do some little bit more illustration over here. Okay, since we talk about some effects called aliasing over here, so basically what we want to illustrate is after the effects of aliasing, if you try to move up this particular point objects, it doesn't really matter which name you actually use to do this operation. Okay, so now you can see that after the assignment over here, P1, you can see P1 is pointing to this object here. P2 is pointing to the same objects. If I want to change this particular object here, it does not matter which name I can use. I can either use P1 or I can use P2. It doesn't matter because P1 and P2, they are indeed storing the same addresses, okay, for the same objects. Okay, so this is I want to illustrate to you. Okay, that's really the essence for aliasing. Okay, so now before aliasing is created, okay, that's one thing, and after the assignments is after the aliasing is created. Okay, there's something I want to illustrate to you first of all. Okay, so now I want you to look very carefully of what I'm going to do now. So first of all, let me say if I have let's say P1 dot move up. Remember, P1 was created as 2 and 3. Okay, and then I'm gonna do, I'll draw a new diagram for you in just a moment. When I say P1 now move up, let's say move up by 3 units. Okay, let me just go back to the illustration over here and then I'll show you. Okay, so now let's go back to a new diagram over here. I'm gonna redraw everything. Okay, so here we got P1 over here. It was created as an object of 2, 3. Okay, so we got 2, 3 over here. So we have point, and then we have x and y, 2 and 3. Okay, and also we got P2 over here, and then we have another point over here, and also we got x and y, and then let's just make sure we got it correctly, and then 4 and 5. Okay, 4 and 5. Let's try the following. You can see, to begin with, before we do the reference assignments, P1 and P2, they point to the same, they point to different objects. They point to different objects, okay? Since they point to different objects, if I try to use P1 to modify this particular object over here, it's not going to change anything on these separate objects. Okay, let's make sure that's really the case, okay? So what I can do is, I can say, once I say P1, then move up 3 units, well, so what I would do, I'll let you trace the method, okay? We have done that for quite a bit of time, okay? So now, if I say move up by 3 units, that means P1, the y, is going to be move up by 3 units, so that'd be 6. Okay, that's what you would do. You just have to somehow trace the definition for move up, which would be P1.y. In this case, P1 is this, okay? P1.y plus equal 3 units, okay? Okay, let me just go back here. So you can see, according to the diagram, after we say P1 that move up 3, he only modifies this object here. That means P2 remains to be 4 and 5. Let's verify that, okay? Let's verify very quickly. Before aliasing is created, we'll say, since P1 and P2 point to different objects, calling P1 dot move up 3 does not modify attribute values of P2, okay, of the object pointed to by P2, okay? So basically, modifying this object here does not change the object that's pointed to by P2, okay? Let's verify that. That means P2 should remain to be 4 and 5, okay? Let's try this one here. So now if I say system.out.println, if I say P2 dot to string, we should still see that before the aliasing, we should have P2, okay? P2 before aliasing, okay? And then we should have still 4 and 5. Let's try that. Okay, you can see that P2 before aliasing, we got 4 and 5, okay? So now, let's go to the point that after we do the assignments, P1 is assigned to P2. First of all, let's review what's going to happen. When we say P1 is assigned to P2, okay, let me use a different color here. When I say P1 is assigned to P2, that means whatever address that is stored in P2, we're going to copy that over and replace the current address that is stored in P1. Conceptually, we're going to say P1, rather than pointing to this object anymore, is going to point to this object over here. Okay, that's what you will do. So that means we are now going to have 2 pointers pointing to the same objects over here. So you might have the question about what happened about this particular object here, because apparently there's no arrow pointing to it, so you don't have to worry. There's something called automatic garbage collection. Garbage collection in Java. So in this case, this object here, which has no pointer pointing to it, will be automatically garbage collected. You don't have to worry about it. Okay, the Java compiler at Java runtime will make sure it's taken care of well. Okay, so now let's go back to this. after this assignment over here, if I now try to do again the same line, okay? If I try to say after this assignment here, after the aliasing is created, what I would do is I would say P1 dot move up over here and 3. So now you can see I try to do the same line over here. Before the aliasing was created, P1 and P2 point to different objects. So that is why when I say P1 dot move up, it does not affect P2, right? Does not affect the object that's pointed to by P2. However, after I do P1 is assigned to P2, we know that now P1 and P2, they're now pointing to the same objects. So now the question is, if I now say P1 and move up again, is it going to change the object that is pointing to by P2? Apparently yes, right? Because of aliasing, the same object has two different names. So now it doesn't matter which name you use to modify the objects. As long as you use one of them, it's going to modify the object and the effect is going to be visible by all the other names, P1 and P2 in this case. Okay, let's illustrate this. After we say P1 that move up, what's going to happen? Okay, I'm just going to just copy this line here and I'll modify the comments accordingly. So now this will be P2 after aliasing. So now after aliasing, P1 and P2 are pointing to the same objects. So that means whatever effects you try to apply to the objects using P1 is going to be also visible by P2. Okay, so that means P2.toString is not going to return like a 4.5, 4.0, and 5.0 anymore. It's going to return something different. Okay, why don't we have a look at what it is going to be, and then we illustrate this on the iPad. Okay, so what we'll see is, we'll see that over here, you can see that rather than, you can see before the aliasing occurs, we got 4.5, 4.0, 5.0. Now we got 4.0 and 8.0. Okay, so now let's see that what's going to happen, what actually really happened here. Go back to the iPad over here. So what we did was, okay, let me just put it here. We first of all, we did P1 is assigned to P2, right? It's going to make sure these two reference variables point to the same objects. And then when we say P1 dot move up by 3 units, okay? So P1 is over here. Using P1, we can look up to see this is where the object is. And then P1 dot y is going P1 dot y, which is at the same time also P2 dot y, right? And then P1 dot y is going to be incremented by 3. So that means it will be incremented to 8. Okay? But now we can see that P1 dot x is still 4. P1 dot y has become 8. What about P2? You can see P2 is pointing to the same object over here. So P2 dot x 4 and P2 dot y is 8. Okay? So you really want to compare these two scenarios before aliasing and after aliasing very carefully. It's really important. That's a very important learning outcome for this course. Okay? So now I want to make one more annotation for you. So now you can see that P1 dot y is also P2 dot y. Okay, that's really important to notice because of aliasing. Okay, again, this line over here creates aliasing. Okay, and then here you can say due to aliasing, a change to objects pointed to by P1. Okay, let me just will also be visible from P2 because P1 and P2 they refer to the same objects. Okay. Okay, that's something you really want to study over and over to make sure you really got this concept. It's really important. Okay, aliasing effects only occurs for reference variables. When we talk about integer variable, double, boolean, character, float, we don't have this aliasing effects. Aliasing effects is only the case for reference variable, because for reference variable, we store addresses of objects, okay? Okay, let's go back here. So now, after this, we're going to actually show you how you can declare another model class, which is going to use declare attributes of reference types.